So the next step that we need to provide, like after the boundary conditions, is the initial conditions. So here we are saying that in the volumetric region, we have oxygen and nitrogen, basically air, that is at a particular pressure and temperature. So these are called as initial conditions. Usually these are quite okay. You can use any values you want. Even if you change the values a little bit, it doesn't matter. Then comes your turbulence modeling. So here you can see that I'm using RNG K epsilon, which is not a good model. I would use something like K omega SST along with the constants that's provided. Then looks like there's an error. Okay, so this has to do with converge. Let me just create some passives here. Then grid control. So this is where the computational mesh is. So I'm basically providing the base grid, and then I'm using something called as adaptive mesh refinement. I can just show this in action. So for example, in this car, if I enable the cut plane and maybe hide the car itself, and for the cut plane, if I enable the edges, then this is a cut cell Cartesian mesh. So the cut cell Cartesian mesh is very accurate. It has got very low numerical diffusion. So it's a very nice, high quality cell. So this right here, if I use some colors, so this right here is a base grid cell, and this is called as adaptive mesh refinement. So note what's happening, right? As the flow conditions are becoming chaotic, the solver is automatically refining the cells on its own without you doing it. This way, you can actually use the cells very, very efficiently. And adaptive mesh refinement is one of the most popular technologies in CFD. And with Converge, you can do that in complex geometries, which is a huge plus point. With ANSYS Fluent, you cannot do it that effectively. So because of that, the results, it will take you much longer to get results with ANSYS Fluent when you do a transient simulation. Basically, look at our post-processing. So post-processing is the art of, basically creating images like this and analyzing the fluid flow. So you can create a cut plane and you can look at velocity magnitude. For example, in the same cut plane, what I can do is I can disable my mesh and then look at pressure and see where the pressure is, right? So this way I know that, okay, these are my high pressure areas and low pressure areas. So whenever there's high pressure and low pressure, that are going to meet, you'll always have vortices, right? So that is where, when I enable this guy and, you're going to see this type of a vortex. Because what's happening is your flow from a fluid from high pressure is going to come into the low pressure region and vice versa. And in this case, what we do is we do have some kind of an arrangement to block that, which is basically this rear end plate. Okay, so this part right here. So this part is basically used to kind of prevent that. And but still you have these vortices getting generated anyways. And as long as you're getting these vortices, as long as the flow is turbulent, that means you're preventing your flow separation point, which is good for aerodynamics. So when you're doing post-processing, it is not only about creating these nice looking images. It is more about, okay, what type of an engineering story that I'm making up here? What am I understanding from this type of simulation, right? That is more important. And you have to support your understanding by numbers. That is where you create line plots, charts, and everything. Okay. All right, guys. So with that, I think I ran over my schedule, but that's fine. I think in this introductory presentation, you guys hopefully learned something about aerodynamic simulations with respect to formula cars. I hope you found this session useful. Now, the workshop is officially done. As far as certifications, you will be sent an email in roughly 2 weeks' time, along with the certificate and the recording of this entire workshop. Everything will be included. And please make sure that you check your spam folder and your promotions folder. Okay, I hope that makes sense. All right, guys, I hope all of you found the session useful and you learned something. We do have other workshops coming up. So if you're interested in that, please attend that as well.